So now I will leave the floor to my colleagues. They will go through the 6 initial services in NextOcean, starting with Pedro for demos. And Pedro, the floor is yours.
Okay, thank you very much, Hervé. Good morning to everyone. Thanks for having me. So I'll start describing the services that are being developed both by Demos and IPMA. So if you can move to the next one. So yes, exactly. The first service that I'm going to describe is the characterization of fishing areas. And the idea there is to generate fishing bulletins indicating potential favorable productive areas for fishing tuna in the North Atlantic, which is the first fishery we are addressing in this application. So of course, the typical applications there, we can see applications for the fishing industry to improve their efficiency. So spending less fuel and emitting less carbon to provide the same products. But we can also see applications for other users. For instance, environmental researchers that are interested in understand how the fisheries are taking advantage of these productive areas. So, like I said, this is currently available for the Portuguese waters, but it's on the North Atlantic, but it's limited to the tuna fishery, but it can also be extended for other areas depending on data to validate the services. And there's a lot of data being deployed here, mostly the maps that are being produced using data from Copernicus Marine Service, but we have to do the validation of this with the actual catches and the actual fishing activity that we retrieve from IPMA and DGPM in other projects. So that's the kind of validation that we're performing. If you can proceed for the next one, yes. So yes, if you can go clicking now, there's some animation. I'm trying to show here, we start to produce these maps by separating the coastal zone from the oceanic zone. So this is something that we're doing because we have different algorithms for the coastal and the ocean and the offshore zone. So we have this coastal stretch of just 200 kilometers. Within this area, we are looking for coastal fronts, for ocean fronts. So in this case, thermal fronts on face-to-face temperature. After we find these areas, we have strong changes on strong gradients on temperature. We can consider them to be thermal fronts, and then we create a buffer area of around 20 kilometers around these fronts. And then using chlorophyll data, we select just the clear water. Since tuna is a visual predator, we want to have those areas as potential fishing areas. And the result is these maps, as you can see here. The first one is with colors, different colors for different days, where you can see the ocean fronts. In the second map, you can already see the potential fishing areas. So these fronts, together with the 20 kilometers buffer zone to the clear side, that's where we expect to have better fishing. Again, this is also being presented for multiple days, so you can see a little bit the progression. Second service that we're developing, this one only by demos, is looking at the fish provenance and ecolabelling. So we're trying to develop a tool that monitors fishing activities and then can be used by certification authorities, regulators, and all sorts of users that are interested to have information on these fishing activities. So we can see applications for regulations on fisheries, of course, but we can also see application for environmental monitor of marine protected areas. We can see, and we're also quite exciting with the certification market. So we want to introduce this information in the supply chain of fishing. And again, this is currently available only for Portuguese waters, but it's also possible of being extended. Demanding, of course, more data for validation. And in this case, the data that is based in the production, that is being used for the production of this data, of this information, is AES data retrieved from commercial providers. So next one, just so I can show a little bit of an example how this works. We get these AES points, and which are, of course, connected to a specific fishing vessel. We can then separate the different fishing trips by understanding when they're leaving and when they're returning to the port. And we try to identify within those points, AES points, which of those are corresponding to times in which the vessel is fishing, in times in which the vessel is just traveling. With this information, we can then try to look at the specific areas. What I'm showing here is a marine protected area on the Azores archipelago. And as you can see from the red dots there, you can see that some of those fishing trips actually had fishing activity within this marine protected area. So of course, this is just a first layer of information. It has to be analyzed to understand what are the implications of this fishing if that is not allowed in that area or different regulations may apply. So this is just an information service that can be used for different ends for the users. Next one. So this information is also aggregated for all different fishing vessels or for a specific fishing fleet, and it can also be filtered for different seasons or months. And then you can have this aggregated maps of fishing activity, where we can see, this is of course only the red dots coming from the fishing trip, so we can see where the fishing activity is being performed within an area of interest. And this is, we also have a possibility of adjust this temporal and spatial resolution depending on the application and the availability of data. So what I'm showing here is just a seasonality analysis, looking again at the Azores archipelago, but we can see, next one, please, that we can also convert this information into time series to understand how the fishery activity is varying along the seasons along the year. So this is just one application, but we can see different uses for this information as I explained before. So we expect to develop this within NextOcean co-design activities to further improve the service.
Thank you very much, Pedro. So we'll take questions at the end of the session. So now we move on with our partner PML and Andrey, which will present the next two services. Andrey.
Good morning, everyone. I would like to present two services developed by Plymouth Marine Laboratory. And the first one is Fisheries Monitoring and Surveillance Service, FMS service, which was designed to monitor illegal fishing activities in the area. Originally, it was in West Africa, Ghana. And usually for monitoring fishing fleet, well, many organizations use automatic identification system AIS data, which shows the location of each vessel, identification number, destination port, size of vessel, and what kind of vessel it is. And if some vessels are involved in illegal fishing activities, then they try to hide their identity by switching off a system installed aboard of vessel or spoofing this system, and then this vessel become invisible for monitoring. And in this service that we developed, we use satellite Earth observation data to look at the vessels in the region of interest. Any vessels can be detected from space, the vessels that use AIS and the vessels that spoof AIS system. We use Sentinel-1 synthetic aperture radar data to detect vessels in the region, and we identify this vessel's location, dimensions, and then we compare this data to AIS data to identify vessels that switch off or spoof AIS system and can be potentially involved in illegal fishing activity. So this system provides maps of vessels in the region, which shows location of vessels that use AIS and vessels that do not use AIS. Such vessels are shown in red in the middle of the slide. We also show tracks of vessels provided by AAS, dimension and identification number of this vessel in our service. And this service provide latency of about up to 12 hours when we use Sentinel-1 SAR freely available data provided by the European Space Agency. But end users can reduce this time by using commercial satellite sensors, but in this case, the service will be more expensive. The next service that we developed is called Monitoring of Aquaculture Structures, MAS service, which maps aquacultures of different types like fish cages, shellfish farms, or floating houses and jetties used to service aquaculture sites. Again, we use remote sensing data to map these objects, and the service provide quite accurate estimates of locations of fish cages of size up to several meters. And this map shows the location of these cages at different moment of time, so that we can produce time series of these maps that will show you how aquaculture structures have been transported to different locations, or new structures were deployed in the area. This slide shows an example of aquaculture map in the Malampaya Sound, Philippines, Palawan, obtained in 2016, shown in red, and 3 years after, in 2019, and these structures are shown in yellow. So we can see how much changes this area went through in these 3 years, and how aquaculture has been developed over these 3 years. Currently, this service covers Palawan, Philippines region, but can be extended to other coastal areas covered by Sentinel-1 SAR sensor. We also apply the service to map salmon cages in the north of Scotland. This illustration is given on the right, and these maps were validated by using Google Earth high-resolution images. Thank you.
Thank you, Andrey. And we conclude this series of presentation on services with Marion from CLS.
Good morning, everyone. So I will present you now the services that will be developed by CLS in the frame of NextOcean. So the two services will be addressing more aquaculture and fish farms industries. So the first one, the site risk assessment service, it's addressing all the issues of pollution that can impact on the sites, on the aquaculture sites. So the idea is to provide the fish farmers the information on the environmental monitoring on their sites, and to provide them with the information of potential pollution that can have an impact on their sites. So today we see different types of pollution. First one would be the oil spills as marine pollution. So oil spills from vessels passing at the vicinity of the farms. For this oil spill monitoring, we will base the service on the use of Sentinel-1 data, of synthetic aperture radar data, on which we can detect the pollution. With that, we can also do some prediction of the trajectory of this oil spill to see if it will impact the sites. And we want also to work on other types of pollution that we can refer to as pollution, and it can be, for example, harmful algae bloom, so bloom of algae, or marine heat waves, so extreme events that can have an impact and can have a pollution impact on the sites. For this last two environmental extreme events, can you come back a little bit, please? Thank you. We will base our service on the environmental data that we can find from the Copernicus services, and to elaborate some early warning on the environmental data that can help us to define the favorable environmental context of the occurring of these extreme events. For the site risk assessments, we have two types of application that can be derived from this. First one is an early warning in real time. So we want to provide to the fish farmers an early warning system to help them anticipate the arrival of pollution and to prepare some mitigation plan. So it will be in real time the detection of the oil spills on the synthetic aperture radar Sentinel-1 data. With this, we can actually do that with a revisit time of 2 days over Europe and the Mediterranean Sea using the Sentinel-1 data. This revisit period can be increased if we go and process commercial missions using SAR data. So first one would be, as I said, an early warning in real time, and the other sub-service would be also to provide reanalysis of particular events. So it could be on marine oil spill pollution, but also on extreme events. So providing some information on a particular event to claim for insurance, for example, or to help to understand a particular event. You can go to the next slide, please. Just an example of the products that will be delivered in this service. So you can see on the left, the first image on the left represents a SAR image processed, on which you can see the result of the detection of an oil spill with the brown area. And you also have all the vessels that have been detected in the vicinity of this pollution, and the service will provide some information on the potential polluter that was at the origin of this pollution. On the right side, you also have some environmental data showing harmful algae bloom on the top right, and on the bottom right you also have another detection of oil spill showing in red the results of an oil spill that was detected from illegal venting. So the second service that we will be focusing on and develop in the frame of NextOcean will be again related to pollution, but this time it will focus on pollution that are coming from the fish farms. So while we are in the first service, we are really looking at environmental monitoring and helping the farmers to monitor their environment and to prevent their production from pollution. From being polluted. In these fish farm impacts, we want to provide some services to help the fish farms to prevent them from polluting their environment. So it will be mainly based on or focusing on two applications. First one will be to detect the pollution as for oil spill. So coming from the grease of the fish nourishments that are deployed on the fish farms. And the second one will be focusing on the farming materials, because we know that now some of the aquaculture sites are installed in very exposed area, exposed to strong currents and to bad weather. And there is a risk of losing some fishing materials and to adding some plastic pollution to the ocean. So the idea of this service is to give some tools to the fish farmers to prepare and to prevent these pollution, and helping them to prepare the operation for fish nourishment, for operation and maintenance on the cage, or to do some mitigation actions on this potential pollution. So if you go to the next slide, these are an example of the products that we will be able to produce. So on the top right, again, you see that we are able to detect the pollution coming from a fish farm, probably after some nourishment or some grease added to the water. And on the two other images, you can see a result of drift model coming from some aquaculture sites or from on tropical hills area, where using the currents and dispersion by the current and the wind, you can actually see the trajectory of some particles coming from the site and dispersing and propagating into the vicinity of the cage.